Greetings to all dear friends. The first work is the Mausoleum of Avicenna, designed by Master Husheng Sihoun, and we will try to simulate it using its photo. As you can see, this structure consists of 12 columns, and the height of each of these elements, each of these columns, from top to bottom is 23 meters. And then, on top of it, there is a cone-shaped object, and at the bottom, we have two cylinders. In terms of form, it is made up of very simple shapes, but it's the proper arrangement of these elements next to each other that has turned this work into a distinctive and lasting monument. Look, now the structural elements we have, the height of their base, actually, what do you call it? Not the thickness. The width of the base is larger than the width at the top. Now I'll tell you the dimensions. Let's look at its other photos. From another angle, it's a hollow cylinder. Here it's clear that we have a cone, and these structural elements, naturally, their cross-section is clearly rectangular. We can see this work from another perspective as well. And this is also one of the few photos that exists from directly in front, meaning we can see it from a straight-on view so that we can take measurements from it and be able to draw this structure. Here, too, we see another view of the Mausoleum of Avicenna. Now we'll move into AutoCAD and try to simulate this. Alright, I've entered the AutoCAD workspace and drag and drop my photo in the AutoCAD environment, so I can extract the measurements from this and do my own drawings based on it. We already covered how to work with images and import them into an AutoCAD file in detail in the 2D AutoCAD section. So, the only information we have about this project is from the very top of this column to the bottom. The first thing we should do is put this on a sheet of gray, so it doesn't keep freezing up. And then, so I can see the lines I'm drawing on it, I select the image. This ribbon context menu opens up here at the top, and I increase its fade. I increase its transparency so that I can do my own drawings here. Now we can see our line better. I turn on F8, from the top down to here. Now let's say it's about 30 meters, so this part has become 3/10. We say it's about 30 meters, even though we know it's around 23 meters here. So first, to change it from 3/10 to 30 meters, we actually use a scale. First, let me switch my keyboard from Persian to English. As enter, select the object, enter base point, M. Now, wherever it is, I make it 100 times bigger, so that now I can draw based on meters. Alright, we see that here, for now, we want to fix its scale. It's about 30 meters. Whereas in reality, it's 23 meters. That means 23 divided by 30. I'm doing it with a calculator right now. It comes out to 76 hundredths. Alright, so I need to give it a scale of 76 hundredths. As C, enter, select the image, enter, from anywhere, it doesn't matter. 76 hundredths. Now let's see if our height turned out right. From here to here is about 23 meters. Yes, so why did we do this? So that we can have the correct height ratio. We can read the width ratio from here, because we don't know the size of this tower's cross-section. 4 times, when we don't have any dimensions or measurements, we can use this method, because for many of these, the plan might not even exist. Alright, we need to make the image a bit bigger so it lines up properly. Let's make this 23 precise too, so we don't have to worry about it anymore. Look, Right now it's exactly 22 and 6, but it needs to be 23. So 23 divided by 22.6. If we multiply it by about 1.02, it should work out. S enter, select enter, 1.02 like this. Now look. From here to here, yes, it's 23 meters. Now down here, we take 9.7, almost 10 meters. Or if you bring it here, if it comes out exactly, it's the same 9.7 for the lower diameter. 9.7 for the upper diameter. For example, it's 7.7. 9.7 and 7.7. Alright, now we come here. We need to choose the diameter, of course, 9.7. Now another circle for the top of the tower, again with a diameter of 7.7. That's right. Let's check it one more time to be sure. From here to here, 9.7. Again, from here to here, 7.5. Now, approximately. We double-click on this. We set its diameter, 7.5, and it calculates the radius itself. Okay, now we move into the 3D space. We said the middle circle should be at a height of 23 meters. Like this. This is the top circle of the tower. This is the bottom circle, the upper section and the lower section. Alright, now we go back to the plan view, double enter. The top view actually shows the thickness of each of these. It's about 35 centimeters, the thickness of each of these columns. And I read somewhere that the width of the column at the bottom of this tower is 1 meter and 17 centimeters, and at the top of the tower it reaches 92 centimeters. Now let's draw it. What are we going to do? We want to draw one of these elements, one of these 12 columns. Once we've drawn it, then with Array Plus, remember Polar Array, which we actually used in the 2D AutoCAD section, will come and rotate it around an axis. So what we need to do first is draw its cross-section. A rectangular cross-section with dimensions of 0.35 by 1.17. Alright, once again, rectangle. Press D, enter, so the length and width switch places instead of rotating it. 1.17, enter. 0.35, enter. Now, how do I place it here? I need to divide the circle into 12 equal parts. I need to divide it. Actually, what does that mean? How do I do this? I select D-type. First, I make my points bigger. Something like this. Then, using the divide command that we learned in 2D AutoCAD, I divide this circle into 12 points. Okay, for the upper circle as well, divide, enter, 12, enter. One more time, divide, enter. Select the object 12, enter. Alright, now I use M, enter, and select its center. I place it at the center. How do you select its center? Both 2D snap is on, and 3D snap as well. And now I need to draw another rectangle from here. This time, 0.9235, enter. Now, this is the top section of the tower. Enter. Grab it from its center and bring it up here to place it. It placed it in the wrong spot. Enter. Let me put its center on the center of this point. Alright. Now, using the p-type view, I'll remove the points. Basically, I'll shrink their size so they're not visible. You see, now we've drawn the lower section. It's 35 centimeters thick, and its width is 1 meter and 17, the concrete column. On this side, it's again 35 centimeters, but on the other side, it's shrunk to 92 centimeters. We want to connect these two so that we have one of our column elements. We learned this in previous sessions with the loft command. The lower object froze for a moment. The upper object connects by itself in cross-section mode. That's why there's no curve at all. Just hit enter, cross-section, and that's it, the job's done. One of these columns has been drawn, easily. Now we want to rotate this all around the object. We said there are 12 columns, so we'll just select it using the plus array tool. Enter asks us for an axis. We say the middle of this, you see. Now there are 12 columns. Here, I set the number of items to 12, and then I hit close array. These columns were drawn this beautifully. Okay, now let's go into the plan view. Why 12 columns? Actually, the idea during the design was that, for example, because Avicenna mastered 12 fields of knowledge, the columns were also set to this number. Now, what we need to do is start from the lowest layer. We have 2 cylinders here, each with different diameters. Where is it? Let's check the photos and see. Take a look here. First, we have a hollow cylinder that starts from the highest point of this column, and we need to see how tall it is up to here. Then, there's another cylinder lower down, which is wider. You can see its radius is larger, and it's set inside the column. We need to check how tall this one is. Now, let's see if it's clearer in the next photos. I think you got the idea. I'll also share the photos with you so you can see. Let's go back to our AutoCAD file. Here, we need to take a measurement from the top point of the column to here. B to here. I think it's about 1 meter and 20 centimeters. This cylinder comes here, and then this one as well. Around 40 centimeters, about 45 centimeters too. This cylinder is bigger. Alright, let's go ahead and draw it. We select a cylinder. This one goes up to here. Now, if we want to set the height, how much was it? I think it was 1 meter and 20 centimeters. This is the first cylinder, right? We said it started from the top of the column and came down 1 meter and 20 centimeters. Now it needs to be hollow. So, how do we make it hollow? For example, we use the shell command so we can practice all the commands. Select remove this face. Enter. Now you say, give it an offset. I think an offset of 2/10 is suitable too. Enter, and it's done. Now it's hollow. Alright. Now we need another cylinder. This time, we said it should come up to here, covering a bit of the columns too, but with a height of, say, 40 centimeters. We said 45 centimeters, so this is it. So how far down should this enter? 1 meter and 20 centimeters. It went down 1 meter and 20. Alright, now this one also needs to be hollow. You see, it exactly cut through these columns, just like we saw in the pictures. Now go back and look at the photos again yourself. If we loosen this, it won't be hollow anymore. We want it to be hollow in such a way that the inner cylinder above it is also visible. So we need to select it. Offset edge. OK, it says select the face. I'll select this face manually now. Let's specify a value. For example, here. Alright, that part is done. Now, with the push/pull tool, we pull this upward. If we pull it, it becomes a hole. OK. Let's see if everything looks right. Yeah, it's hollowed out, and you can see the upper cylinder. Very nice. Now, what do we have on top? Let's check the pictures again. Look, it seems like there's another cylinder placed on top with a thin wall. After that, the cone starts, and even the top of this cone isn't sharp. You can see exactly, first the cylinder, then the cone. So here, the cone hasn't just sat directly on top of these columns. Alright, let's open up the AutoCAD file. We need to have the measurements. Now, plan, press enter twice. One more time, plan, press enter twice. This is our reference, so let's see how much it is here. For example, here we have a 50 centimeter cylinder, 50 centimeters. Let's also check what the radius is up here. No, it's not 50 centimeters. From here to here, for example, or maybe 20 centimeters. Let's say we consider the upper radius up here. 50 centimeters is the height of this. And now we need to see what its radius is. Its radius is exactly the same as the cylinder underneath it. That's fine. We just need to see what its height is. We have to consider it from here up to the top of the cylinder. About 5 meters. Alright, so first, here we need a cylinder from the center. Up to here, okay, half a meter upwards. After that, we need a cone. Let me erase this circle now. We need a cone, one from the center again to this edge. Now, how far up should it go? We said 5 meters. It was a bit over 5 meters. So, let's say 5 meters like this. Now, as we said, at the top of the cone, of course, if we double-click, its top radius here, for example, if we set it to 0.2 or maybe 0.25, so that the top isn't completely sharp, it creates a shape like this for us. Exactly like what we saw. We set its dimensions and measurements based on the reference. Now, it might be off by a few centimeters, but the proportions are exactly maintained. Now, let's draw a box underneath it. Downwards, for example, 5 meters. In this way, the Mausoleum of Avicenna was easily drawn. Take a look at it from different angles, other views as well. Be sure to practice this yourself and try it at least once. You'll really get the hang of the commands. Practicing this is very important. Let's check out the sketch mode. The X-ray view inside the tower is also visible, like this. So this was the project, basically, the Mausoleum of Avicenna that we drew.